Hello everyone, I'm really happy to be here, really happy to talk to you all, and let's enjoy this session, this conference, and let's start. So, in this session I would like to talk with you about the next topic, how to build low-cost CI/CD solution on top of AWS. Okay, this talk will describe my own story and my own experience, and you can take it from here to wherever you want. You will see what I achieved here and what were my issues through my journey. So before we start, I would like to introduce myself. So my name is Valera Bronshtein. As I said before, I am head of DevOps at Memphis Dev. Memphis Dev, it's an open source real-time data processing platform. Okay, in short, what we are building a full ecosystem for in-app streaming use cases. You can read more in our website. I am 31 years old, married with 2 wonderful kids, more than 10 years in the IT world. Okay, through my career I started as a Linux administrator, storage administrator, consultant, senior consultant, solution architect, and where I am today, a head of DevOps at Memphis Dev. Okay. So enough about myself. Let's start with the story. Okay, this is my Jenkins story, and I will try to explain it and tell it in the best way. Hope it will be clear. So how did it start? Okay, we are a startup, and when we started, we wanted to do it quick and dirty. Okay, that's the exact explanation. Quick. We need to run fast to do as much as possible in a small amount of time. So we looked in some point. We looked for an automation tool, some CI/CD tool, and our specific requests. With our specific request, we understood that Jenkins can be the best, the best and the best and the quick and dirty solution. Okay, so we want Jenkins, we install it, and we starting to use it without any deep dive configurations and so on. Just as it is, let's use it. And in the first time it works good. Okay, but through our journey, we understood that the initial setup is not working so well. The build's taken so much more time. The disk getting full too quick. So we started to upgrade our Jenkins instance until and then we came to what I call Jenkins Ninja. Okay, a really powerful instance with a lot of CPU, a lot of RAM that can do a lot of workloads, heavy workloads in the same time. But through the time, we get to the new issues, to the new obstacles that we need to solve. And what we found, okay, what was bothering me as a DevOps engineer in the company, what I wanted to achieve in the future. So let's start. The first issue is, of course, single point of failure. You can understand it by yourself, okay? I have only one machine, only one instance, and how much it can be powerful as far as I want, but still is one. And when something unexpected happened during the build of one of the pipelines, it will affect all the rest. And it's okay when it's happened in the day-to-day work, but it's less okay when it happens when you are in the middle of the release and you are pushing your code to the production, to the customers, okay? So we don't want this scenario to happen. We need to think how to be more. Excuse me. We don't want this single point of failure happen. That's it. That's the point. Okay, and when we have only one Jenkins instance, we cannot run builds in a parallel way. No parallelism. Okay, and it's obvious. Okay, in case we have some build that will take all our resources, there will be no resources for other builds, and you can take it to every scenario you want. MongoDB that catch the port, and another build that use another MongoDB instance cannot run on the same node because the port is already in use, and so on. And as you can understand, the first 2 points already lead us to the third one. We need monitoring, and we need to monitor everything, and we need to be with the eyes on the product every day, every single moment, because with this Jenkins instance is production for us, for me, okay, as a DevOps engineer in the company. I need to make it. I need to have it up and running all the time. And I don't want to do this kind of job on my daily basis. I want to be sure that my Jenkins is running all the time, no matter what. Okay? And of course, we are growing, and the build is growing with us. Okay? So, now when we understand what are the problems, let's see how we can solve them and what we want to achieve. So first of all, I want to be high available. I want to be HA all the time, no matter what. In case one of the pipelines is killing my node, I want to kill this node and run the pipeline on another node without any regrets, without any thought about maybe I have something on this particular node that I need for my next build. I don't care. I want to destroy it and create another one. This is HA in my perspective, okay, in this specific scenario. I want to run parallel. I want faster builds. I want to reduce time to market. I want to run as much as parallel as I can, as my setup can afford. If I need to run 4 builds that do the same, I want to run 4 builds in the same time. I don't want to wait until each one of them is in and then run the second one, the third one, the fourth one. Okay, I don't want it. I want in parallel. Another goal that I wanted to achieve, and eventually we achieved it. I want to run a dedicated compute node per pipeline type, per pipeline logic. Okay, I'll explain. Imagine yourself, I have one pipeline that perform all the workloads that are massive workloads that have a lot of throughput, a lot of CPU usage and RAM and so on. But on the other hand, on a daily basis, I have some cron jobs that push data to the databases or get some backup from my GitHub repositories. I don't need this kind of high performance machine from the first pipeline to be involved in the second pipeline. The second pipeline can be run on some free tier, maybe T2 micro, T3 medium, or something like that. Okay, so I want some kind of logic that will see which pipeline I run, and after that trigger the proper instance into the pipeline, and you will see how we achieve it. And of course, the build. Okay, so let's talk a little more about the build. You can make all the calculation I did here by yourself. You have a AWS calculator, pricing calculator, okay, and you can use it and see the numbers by yourself. But let's take my scenario. Scenario number one, before the optimization, my instance type, I eventually came to 32 vCPUs and 64 RAM. And the next step was already 64 vCPU. I needed this machine because the pipeline took my pipelines took all the CPUs and all the RAM from the server in each build. Okay, so this machine was on demand, and I will explain why. The Jenkins Ninja run on 24/7, so it's a monthly usage. Okay. And as you can see, this is my estimated cost and that time. Before I jump to the next level, to the next instance type, the 64 vCPUs, I didn't want it. So this is why we started to looking for another solution. And you can ask, why not on-spot instances? And okay, these are the numbers for the on-spot instances. But you know the Murphy law. When you need it, it will happen. And I mean, when you are in the middle of the release and something happens, your machine will be destroyed because in some reason this spot instance is needed for someone else. Okay? It will happen in the middle of your release. Believe me, this is how Murphy law works, and we were there. I was there. Okay? You don't want to be there. So this is my scenario. So scenario number one before the optimization, and this is the numbers. Okay, let's go. So now when we have some background and we understand what were the issues and what was the goals that we want to achieve, let's talk about the solution itself. So before we dig into the solution and the architecture, I want you to see, to show you some diagram, okay, let's say it like this, how I changed the Jenkins Ninja into the Jenkins Ninjas, okay? So now I have only one instance, the Jenkins Ninja that will coordinate all the others agent, all the other ninjas. The master Jenkins will say them what to do and which pipeline to run in each and every minute. Okay, so let's see how to get there. How it works. Imagine yourself, you are starting your day, you are logging into your Jenkins UI, choose the pipeline you need to run and click on build now. Okay? In a regular scenario, build now will trigger the pipeline and it will start running on the same instance. Okay? My scenario is working like this. Build now will trigger the relevant fleet group. Okay, fleet group. I will show you later in the short demo how it looks and what I mean to. But in 2 words, I have a fleet for every pipeline group that I want to divide between them. Okay, and you will see right now how it works. The relevant fleet group will trigger the EC2 fleet plugin, okay? And the EC2 fleet plugin knows how to connect to AWS and how to run the auto-scaling group there. I have a number of auto-scaling groups, and each one of them that was triggered will run the relevant launch template. In this template, we can configure this instance type, network configuration, security groups, and so on. But something to mention, and it's important, you don't need to choose one specific instance type, and this is the beauty in this solution. Okay, you can configure in the auto-scaling group, you can configure a group of instance types that suits you, that can perform the workload you need, and the auto-scaling group will choose them automatically in case one of them is not available in that specific time. I don't know, we are using spot instances, and it can happen that some kind of instance is not available in the specific time you need it. So the auto-scaling group will choose another one, and you will not feel it, okay? Your pipeline will starting. So we choose the launch template, we choose the instance type, we are starting the user data scripts. They are part of the launch template. The user data scripts are as simple as that, are the prerequisites for our build. If I need during my build libraries for Node.js, or I need to install some specific version of Java, I will do all of these prerequisites in the user data scripts. So when the EC2 node is coming up, it's already have all the prerequisites I want it to be there. So the pipeline can start immediately, okay? So after we finish the data scripts, all the prerequisites, we'll raise up a flag that the status is okay, and our EC2 instances, the Jenkins agents are running. They are up and running. When our master, our coordinator, see that this flag is raised up, it can start the pipeline. So we have some kind of another path to get to the starting to the pipeline to be started, but you can see all the additional value that you get from this process. So you will ask, okay, now we are using auto-scaling groups and launch templates and EC2 instances instead of only one Jenkins. So what are the numbers? Where is the build? Okay. So what we have now? Now we have scenario number 2 after the optimization. In this particular example, I will use for you the same instance type, okay, as I used before. 32 vCPUs, 64 RAM, but this time it's a spot instance that launched with the ASG auto-scaling group. But the interesting part of it, on a day-to-day basis, I have 0 instances up. Okay, it's important. If before this optimization we had one Jenkins, fat Jenkins, huge machine that with a lot of power running all the time, 24/7 for all month, for all year, let's go there. Now we have 0 instances up day to day, and you will see how it reflects into the numbers. I'm taking here some assumptions for the calculations, but they are from the real world, you can understand. Let's say I have 4 peaks in a month, okay? I have a release or some build every week, and I need to, and I have some massive workloads in this time. Let's say every peak like this will use all of the instances in this auto-scaling group. For this example, I choose 5 spot instances, okay? Let's make this assumption for a second. But from my real world, I use only 2 or 3 maybe, and it's not for 4 hours, but I'm taking you to the limit over here. So each instance will have 4 hours of intensive workload during the peak, okay? So you can see this is the estimated cost. You can multiply it by the number of instances, but it's much lower from the previous one, from the $1,000 for one Jenkins machine. And yes, that's a lot. That's a lot. Imagine yourself as a growing company when every month you have you multiply your workload on the pipelines, on the builds. The $1,000 that we started in the beginning, today, after 6 months, after a year, it can be multiplied by 2 or 3 or 5 or 10. And you will understand how this number is so big and so important to us. Okay? The one who is still listening will ask, okay, it's unfair, you know. You are talking about the spot machines, but all this time you still have the Jenkins instance up and running. And yes, you are right. But now my Jenkins coordinator is a different instance type. It's not a free, but it costs me much less. Okay, it's a T3 medium, and honestly, I can take the T3 micro if I want, 1 CPU and 2 RAM, because on a daily basis, this machine the only thing that it's doing is only run the plugins and be a coordinator to point to the right fleet and redirect the pipeline to the right agent in this fleet. That's all. And the estimated cost is, of course, is $45 in a month. Once again, there are theoretical numbers, but I can say from my own experience, they are the numbers I saw before. Okay, before the optimization and after the optimization, our bill reduced significantly. So after we saw all of this theoretical, let's say, information, let's go to the Jenkins itself, and you will see how it's work. So this is my Jenkins, and for this session I prepared 2 pipelines. One pipeline, his name is big EC2. The second one is small EC2. They do the same, okay? They take some GitHub repository and back it up. But one of the pipelines will use, and you can see over here, one of the pipelines, the small one, will use the Jenkins small footprint ASG, and the second one the big one will use the Jenkins fleet ASG. Okay, the names are not so aligned, but it's important to understand. The Jenkins fleet ASG, the first one is for my big workloads, for my massive pipelines that will run all the builds, all the E2E tests, and create images, destroy images, and so on and so on and so on. These builds will use the auto-scaling group that have the launch template with the huge instance type. Okay, as I said before, 32 CPUs, it can be 64 CPUs, whatever I want. The second one is for the cron jobs, for the backup processing. In case I don't want to trigger these massive instances for those small kind of jobs. I want to use something T2 micro or T2 medium, the small instances. 1 CPU, 2 CPU, that's enough for me. I don't care if this particular job will take 2 minutes or 3 minutes. It's okay for me. But I do care how much money, what is the difference in the cost of those 2 instances. And then you have the difference, you can realize it. So now we have the big one I assume, I want to show you how it works, that the big EC2 pipeline will run on this particular node, and the small will trigger a new machine, a new node in my auto-scaling group. So let's say, let's run them and see. As you can understand, the big one will take much more time, that's why it's already here. But the small one, I believe we can see it in a minute or 2 how it starts. So I will run both of them. I repeat myself, they do the same, okay? But one of them will trigger the small group as a fleet, and the second one will trigger the big one. So while we're waiting for it to start, I want to show you how it's configured. And it's configured, it's a really simple process, okay? You need to install the plugin, the EC2 Fleet plugin that we showed before, and then you need to install then you go to the Manage Nodes, Configure Clouds, And from here you can see your Amazon configuration. Okay, in this setup I use AWS, so you see the Amazon EC2 fleet. You can check in your cloud provider how to create those fleets. And the configuration is really simple. The name of the fleet. In this section you will see the credentials, and after that every basic information you need to enter it. What region I want to run into, what's the name of the autoscaling group, and one specific section I want to show to you is the, if you remember from the diagram, I had this OK flag, that everything is okay and we can start run, and this is how I implement it. It's a prefix start agent command that I run before the Jenkins start the pipeline, and it repeats itself every 5 seconds if I remember right, and check if this flag is raised up. It's just simple as that. Okay, this was the first fleet, and this is the second one, the small one. The same credentials, the same configuration, but the autoscaling group is different. Okay, fine. Now I want to show you the autoscaling group into in AWS. Here I've already filtered two ASG that I use here, the small one and the big one, and you can see that the configuration is different. The small one I need maximum of 2 instances, but in the big one I want to go up to the 5 instances. On daily basis, the desired capacity and the mean capacity are 0. Remember it, 0. That's the catch in this story. Okay, so now we can see that okay, already one instance is up, and our build I assume is starting to run right now. And yes, the big one is already finished, and the small one started right now. And when it will finish, the instance that was triggered will destroy itself in 2 or 3 minutes. Just like that. I have another cron jobs, and they will run the same way. They will get up, they will trigger the autoscaling group. The instance, EC2 instance will get up, process all the logic, and go down. That's it. Okay, guys, I hope you enjoyed it, and thank you very much for attending my session. If you have any questions or you need some additional information, feel free to contact me in my email, valera@memphisdev. Feel free to contact me on any social network you are using, and enjoy the conference. Thank you very much.